Now that we know how to find square roots of numerical expressions, let's talk a little bit about how to find square roots of variable expressions. And it turns out there's an easy way to do this. All we have to do to find the cube root of a variable expression is to divide the exponent in the radicand by 3, or by the index. So for example, if we want to find the cube root of x to the 18th, all we have to do is divide 18 by the index 3, and that gets us 6. So the cube root of x to the 18th is x to the 6th. And that makes complete sense if you think about it, because x to the 6th times x to the 6th times x to the 6th is equal to x to the 18th. So to find roots of variable expressions, all we have to do is divide the exponent in the radicand by the index. Another example, if we want to find the square root of x to the 24th, all we have to do is divide 24 by the index of 2. So that's x to the 24th over 2, which is x to the 12th. So x to the 12th is the square root of x to the 24th. And again, that makes sense because x to the 12th times x to the 12th gives us x to the 24th. But of course, it can't be that easy. So let's look at some examples. Here we're asked to simplify these radical expressions. And this is important. Our instructions say to assume the variable can be any real number. Let's pause for a minute and talk about what this means for us. If my variables can be any real number, that means the variable might be a positive number, it might be 0, which is really of no consequence to us, or it might be a negative number. Now, the two most important aspects of this is that my variable might be positive or it might be negative. And because it's a variable, I have no way of knowing which it is. So let's look at the first example. We need to find the principal square root of x squared. And I just put a little plus out in the front of our radical sign just to remind us that we're looking for the principal square root. Now keep in mind that the principal square root of x squared must be a positive value. If it's not, it is not the principal square root. So what is the principal square root of x squared? Well, what variable expression times itself gives us x squared? Well, obviously that's x. But we have a problem because our variable x can be any real number. So that means I don't know if x is a positive number or if it's a negative number. If x is a positive number, we don't have a problem because we were looking for the principal root of x squared. And if x is a positive number, then we've found the principal root of x squared. But if x is a negative number, we have a problem because I have to have a positive response. I'm looking for the principal square root of x squared. Therefore, x must be a positive value. But because my instructions say that x can be any real number, that x might be a negative number. So how do we fix that problem? Turns out there's a simple solution. All we have to do is place absolute value bars around the variable. Placing the absolute value bars around the variable ensures that that value is a positive value and is therefore the principal square root of x squared. Let's look at the second example. Here we're looking for the principal square root of 16x squared. Well, what number times itself will give us 16x squared? Obviously, it's 4x because 4x times 4x gives us 16x squared. But here again, we notice that we have a variable present in our principal square root. Because I don't know if that x is a positive number or a negative number, I have to ensure that it is a positive number. And the only way to do that is to put absolute value bars around that variable. All right, now I'm going to throw a little wrench in this. Let's look at the last example. We need the square root, the principal square root, mind you, of x to the fourth. Well, what variable expression times itself gives us x to the fourth? That's x squared, because x squared times x squared gives us x to the fourth. Can we be absolutely sure that our response of x squared is a positive value? The answer to that is yes. Think about it. If x, the variable x, is a negative number, and it very well could be, because our instructions say that our variable can be any real number, which means it could be a positive number or it could be a negative number. But if x is a negative number and we square x, what kind of value do we get? We get a positive value. What if x is positive? Well, obviously, if we square a positive, we get a positive. So x squared is guaranteed to be positive again. So whether x is negative or positive, when we square that, we're guaranteed that this expression is a positive expression. So x squared is the positive square root or principal square root of x to the fourth. And in this case, no absolute value bars are required because x squared is guaranteed to be positive. Let's add one more example to this slide. Let's find the square root of x to the eighth. And again, we're looking for the principal square root of x to the eighth. Well, all we have to do to find the square root of x to the eighth is divide 8 by 2, and we get x to the fourth is the square root of x to the eighth. But again, we have to ask ourselves the question, are absolute value bars required to make this x to the fourth expression positive? Well, think about it. If the variable x is a negative number, raising it to the fourth power would be a negative times a negative times a negative times a negative, which is a positive value. If the variable x is a positive value, raising it to the fourth would be a positive times a positive times a positive times a positive, which makes it positive again. So whether x is positive or negative, raising a positive or a negative number to the fourth power guarantees that our expression x to the fourth is a positive number, which guarantees that this is the principal square root of x to the eighth, and absolute value bars are not needed. Whenever we find the square root of an algebraic expression, we only need absolute value bars around variables that have odd exponents, not even. Because if we have even exponents, those expressions are guaranteed to be positive. Let's look at this example. And again, our instructions are very important. Here we're asked to simplify these radical expressions, and we are to assume that the variables can be any real number, which again means they could be positive or negative. So let's find the square root of y to the 6. The square root of y to the 6 is y to the third, because y to the third times y to the third gives us y to the 6th. But do we need absolute value bars around this y to the third? Well, if y is negative, we would have a negative times a negative times a negative, which would give us a negative value. So is y to the third guaranteed to be positive? No, we don't have that guarantee. And because we're looking for the principal square root, we have to have that guarantee. So how do we fix that? We put absolute value bars. Let's look at the example on the right. Here we need to find the square root of 25x squared y to the 8th. Well, the square root of 25 is 5. The square root of x squared is x, and the square root of y to the 8th is y to the 4th. So the square root of 25x squared y to the 8th is 5xy to the 4th. But are each of my variables guaranteed to represent positive values? X to the first, that's an odd exponent. X is therefore not guaranteed to be a positive value, so I must put absolute values around my x variable. What about y to the 4th? Y to the 4th, that's an even exponent. So no matter if y is positive or negative, y to the 4th is guaranteed to be positive. So I don't need absolute value bars around y to the 4th because y to the 4th is guaranteed to be positive. So in this example, I only need absolute value bars around my x variable. Let's do a few more examples. Here again, we're asked to simplify these radical expressions, but let's read our instructions this time. This time, our instructions say to assume the variables only represent positive numbers. Well, this is good news for us, because if our variables can only represent positive numbers, whenever we find the principal square root of each of our expressions below, the variables are guaranteed to be positive expressions. So we don't have to use absolute value bars at all. So when our instructions say that our variables only represent positive numbers, we don't even have to worry about using absolute value bars. So let's look at the first example. Here we need to find the principal square root of 9x to the 6th y squared. The principal square root is 3x to the 3rd y. And again, I don't have to worry about putting absolute value bars around the x to the 3rd or the y, because my instructions say that the x and the y are positive numbers. So our final answer here is 3x to the 3rd y. Let's look at the example in the middle. Here we're asked to find the principal square root of the quantity negative 2y squared. Well, this is one of those examples where we have to complete some work underneath the radical sign before we can actually find the square root. So let's square negative 2y first. That's going to give us the square root of 4y squared, because negative 2y times negative 2y is 4y squared. Now we can find the principal square root of 4y squared, and that's equal to 2y. And again, no absolute value bars are needed because we know that our variables can only represent positive numbers. Let's look at the one over here on the right. Here we have the square root of 9h to the 6th over k to the 4th. Well, what fraction can you think of that when we multiply it times itself will give us 9h to the 6th over k to the 4th? The square root of 9 in the numerator is 3. The square root of h to the 6th in the numerator is h to the 3rd. And the square root of k to the 4th in the denominator is k squared. So the fraction, when we multiply it times itself, that gives us the 9h to the 6th over k to the 4th is 3h to the 3rd over k squared. And again, no absolute value bars are needed because of our instructions.